So let's start today's tutorial session. Myself Sahil Gaurav, I am PMRFTA for this NPTEL course Operation and Planning of Power Distribution Systems. What I will do basically, I will I will discuss the tutorial sessions that in which I will take the various type of question that will be very similar to the current assignment and that will help you in solving the current assignments. So let's begin the first question for this tutorial session in which I will discuss the big zero assignment. So the first question is distribution networks. Distribution networks in India are of voltage level 11 kV, 33 kV. This 1133 kV implies to three phase, and the options are line to line voltage, phase to neutral to ground voltage, ground voltage. So in India, if we see the prime distribution networks, distribution networks are of two types in general. First one is primary distribution network, and the this net voltage level of primary distribution network is 33 kV, 11 kV in India. So this distribution networks, these are the power networks used to carry power, used to carry power from substation to distribution transformer. And the secondary distribution network, and the voltage level of secondary distribution network is 400 volt, and that is line to line voltage, and this phase voltage is 230 volt we usually get in our houses. So this secondary distribution, if we can write the power networks used to supply power to individual customers. Supply power to individuals or customers. So these voltage levels are of line to line voltage. So the correct option is A. Now let us see the second question. Second question is valence 3 voltage implies to, and the options are equal phase voltage magnitude, equal line to line voltage magnitude, and C option is each phase voltage 120 degree apart from each other, and D all of these. So I all we know that balance three folder means having all voltage magnitudes are equal and they are phase apart from each other by the angle of 120 degree. So all the ABC are correct. So the correct answer will be D. And we can see that balance theory voltage, the first A option implies that it is having equal voltage magnitude. VA is equal to VB is equal to VC, and let us suppose this it has a magnitude of V. And if we write it in phasor form, then we can write it at taking as the angle of phase A voltage at a 0 degree. So accordingly the phase B will displaced by the angle of 120 degree, and phase C is also displaced from the phase A by 120 degree, having having phase sequence as ABC. So if phase voltage magnitude is equal, then approximate, then also that line to line voltage magnitude will be same. Another property that if we see that VA plus VB plus VC is equal to 0, it is if it is of balanced in nature. So this is the question second, and now let us see the question third. Question third is power loss in transmission distribution line depends on. Option A is inductance, line resistance, line capacitance, and D is line loading and line resistance. So we all know that power loss in transmission or distribution line depends is equal to I square R. So this I depends on I will vary with line loading, and this line resistance. So the correct answer will be D. Now let us see the fourth question. In fourth question, in a three-phase circuit, if phase voltage 220 volt, line voltage would be. So this one is very simple question, and in the big zero assignment, just it will test your basics. So I hope you all will be able to solve all these questions very quickly. So V phase is given as magnitude of V phase given as 220 volt. So V line to line, how we can calculate? So if we see the use the basic mathematics, then it can also derived. So read 3 into 220, it comes out to be approximately 381.05 volt. In a balanced circuit, if we have balanced source, then we can represent it as this one is phase A, phase B, all are displaced from each other at the angle of 120 degree. So want to if we want to if we want to calculate this line to line voltage, we know that VAV or VVC or VCA are line to line voltage, and if we take this magnitude only, then we can write it as if we take this phasor form, then VA minus VV. And if we want to calculate this magnitude of VAB, then we can use the vector subtraction formula that basically tells that VA square plus VV square minus 2VA VV cos theta. We can represent here also. So this one is minus VV. So taking along this VA, this one minus VV, and taking the resultant of VA minus VB, this will give us line to line voltage VAB. So we need to find out this magnitude. So this will use the vector subtraction formula from, we know that since VA, we can also write V magnitude of VA, take it as VB. All magnitudes are equal for balanced scenario. So this will take it as V phase. So we can write V phase square plus V phase square minus 2V phase square, and the angle between VM and VB, that is cos 120 degree. So it will give it as 2V phase square minus 2V phase square, and cos 20 value is minus 1 divided by 2. So this will comes out to be root 3 V phase. So we can finally write, we have derived this line to line voltage magnitude as root 3 times of V phase. And now suppose we want to find this angle, that how much angle it is phase apart from this phase VAB. VAB is phase apart from this phase A. We have taken this A phase voltage as the reference. So we have taken this as reference voltage. So from this vector subtraction formula, we can also find this angle phi. Take, suppose this is phi, that is, and this angle is 120 degree, and this angle is also 120 degree. So if we want to find this angle, then we can use the basic formula that will tell us that VV sin theta is 120 degree, and VA minus VB cos theta. If it is addition, then it will be plus, and similarly in this finding out the magnitude form, it will taken as plus. So VA minus VB cos theta, VB sin theta, we have taken it as V phase. All phases are having equal magnitude. VB sin theta means sin 120 degree, and the value of sin 120 degree is root 3 sin 1 root 3 divided by 2, and VA minus VB, all are having equal magnitude cos 120 degree. So V phase will get cancelled out. So sin 120 degree is root 3 divided by 2, and it is having 1 plus 1 divided by 2. So it will comes out as root 3 divided by 3, and that is 1 divided by root 3. So from here we can get phi value as 30 degree. So this phi will be 30 degree. So line to line voltage leads the phase voltage by the angle of 30 degree. So in this question, it is even asked the only magnitude. So this correct option will be 381 volt. Now let us see this. See the fifth number question. This one is also very basic question. In a three-phase electrical motor rated 2 kilowatt 400 volt at 0.8 power factor lagging, Determine the rated current. So whatever the voltage is given, always assume that will be line to line voltage. If it is specified that it is phase voltage, then take it as phase voltage. Otherwise, if nothing mentioned in question, always take this voltage as line to line voltage and the power as three phase power. So P, we can write P rated is equal to root 3 times VR IR, that are rated value cos phi. So we have given P rated as 2000 watt into root 3 times VR is 400 volt and IR we need to find, and the cos phi is given as 0.8. So from here we get the value of rated current. That comes out as 3.608 ampere, approximately equal to 3.61 ampere. Correct answer option will be C. Now let us see the next question. It is also of similar type question, but in the previous problem the motor rating was 2 kilowatt, but in this question motor rating has been increased and it is of 5 kilowatt. And this question tells us that a three-phase electrical motor rated 5 kilowatt 400 volt at 0.8 power factor lagging. Determine the rated reactive power which the motor will draw. Similar, before that I would like to tell that if this is very basic trigonometric equations used, that is if cos phi is given as 0.8, then sin phi it will be 0.6. This is very useful and needful. Don't always, I suggest you to just if you solve too many questions you will I think able to remember this two forms cos phi and sin phi. If it's cos phi is going to 0.8 then sin phi 0.6, there no need to do the use the calculator. So here in this question we need to find out the reactive power Q rated. So we can write Q rated as S rated into sin phi. So S rated will be what? S rated will be P rated divided by cos phi into sin phi. P rated is given as 5000 watt and cos phi it is also that is power factor given as 0.8 and the sin phi is given as 0.6. So this comes out to be 30,000 divided by 8, 3750 var, approximately equal to 3.75 kilo var. So the correct option will be A. Now next, let us see the next question. The next question is for carrying 1000 megawatt of power. There are two lines. One is rated 220 kilovolt, and the other is of 110 kilovolt. Which line needs lower conductor size? So for carrying the same amount of power, its voltage level is increases, then absolutely the current decreases down. So from here we can say that one having voltage level is higher, then for carrying the same amount of power, the current will flow lesser. So and this conductor size depends on the current carrying capacity. So the correct option will be 220 kV line because it is having the higher voltage level. So you can just for understanding, we can write that power is directly proportional to VI. If you increase this voltage, then I will be reduce for same amount for carrying the same amount of power. And if and the conductor size and the conductor size is directly proportional to the current carrying capacity. So for higher voltage level, it has to the current will flow lesser. So the conductor size also becomes of lower size. So the conductor size directly proportional to current carrying capacity. Now let us see the next question. There are two identical distribution lines. The line 1 is connected to a lump load which consumes 500 kVA at 0.8 power factor lagging. The line 2 is also connected to a lump load which consumes 500 kVA at unit power factor. Which line will incur lower power loss? So we have given two identical distribution lines. Distribution lines, one distribution line having, sorry, one distribution lines having apparent power, sorry, the line 1 is connected to lump load having apparent power value is 500 kVA, and this cos phi is given as, that is power factor given as 0.8 lagging in nature, and the second lump load that is connected to line 2 having apparent power value is 500 kVA, and it operates at unity power factor. So it is asked that which line will incur lower power loss. Line 1, line 2. So we can write it as S is given as 500 kVA, that is apparent power, S1, and in this S2 we can write it as 500 kVA. So in both line it is constant, and if we want to find out the active power, then it is S1 into cos phi, that comes out to 500 0.8, that will be 400 kilowatt, and Q1 will be S1 to sin phi will be 0.6, so it will be 300 kVAR. Similarly, for this, it is operating unity power factor, means cos phi is equal to 1. So S2 into cos phi, that will give us as 500 kilowatt, and Q2 will be 0 kVAR, because it operates at unity power factor. So it will not demand any reactive power from the source, and no reactive power will flow through the distribution line. So from here, basically, what we need to think about this apparent power. We can see this apparent power is same in both lines, and if this is same, then the current will flow through both distribution line will be same. So S is same in both lines, and so that current flow will be also same in both lines. And here in question it is asked that power loss, and power loss, we know that if the current flow is higher, then it will also higher, it directly proportional to current flowing through this distribution line. So current is flowing in both distribution lines same, that so the correct option will be same power loss. So the correct option is C, same power loss in both lines. And if in the same question, just this line 1 is connected to lamp load which consumes 500 kilowatt at 0.8 power factor lagging, and the line 2 is also connected to lamp load which consumes 500 kilowatt in power factor, means in place of apparent power, if it is given as that is reactive power, then which line will incur lower power loss? Then what happens that the load which is having a poor power factor, then that will demand more current from the that will demand more power flow from the distribution line. So in that case, line 1 will consume more power loss, and line 2 will be having lower power loss because S increases in that case. So that is not question, but just for self thinking, you can think about this, that if in the place of apparent power, it is given as reactive active power, that in place of 500 kVA, it is given as 500 kilowatt. Then what will be the correct option in this question? So now let us see the next question. Next question is, three equal impedances are connected in delta across a balanced supply. If the same impedances are connected in a star across the same supply, then what will be the correct options? So let us draw the diagram. So we are having balanced supply, and here a delta connected load. Delta connected load having equal impedances. So take it as Z, 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 and take it as A, B, C. So from this phase A will be connected, from phase B source B will be connected, and from phase C this C will be connected, and all our is in a star. So take it as N, and delta is a three-phase wire system, so there is no neutral point in this. So now from this line current will be IA, this will be VA, this will be VB, and line current will be IB, VC, and this one is IC. So this is for delta connected load. Now the same source is connected to a star. Same source is connected to a star connected load. So let us draw the diagram for this also. So phase will be connected to B point. This one is A, B, C. So phase A, phase B, phase C. It is having neutral point, and this is having also neutral point load in, and the impedances are equal. So as we all know that in delta connected system, line current is equal to phase current, and in this line current magnitude is root 3 times of phase current. Sorry. In delta connected system, line current is root 3 times of phase current, that is not equal. But in a star connected system, it is of equal magnitude, and line to line voltage is root 3 times of phase voltage magnitude. So here if we try to find out this line current in phase connected balanced load, then what will comes out as Ia is equal to, we take only magnitude, then Ia is equal to phase voltage divided by Z. So to better understand it as, write it as I star current, line current in a star load, a star connected load, then it will be VA divided by Z. So this one is first equation. Now for delta connected load, what will be the, just what will be the line current? Take it as IAB, IBC, and this one is ICA. IA will be IA will be root 3 times of phase current. So IAB, we take it as magnitude only. We are not taking care of angle here. So IA is the line current, so we can write it as I delta line current in delta connected load will be what will be the IAB value? That will be VAB divided by Z. Because if you see that IAB, that is connected through this voltage VA and BB. So the difference of VA minus BB, that will gives out the voltage across this impedance, and that will allow the current to flow this in this impedance. So further we simplify this, then we know that this VAB value is comes out to be root 3 times of VA, because same source is connected through both the loads, root 3 times of VA divided by Z. So it comes out as 3 times VA divided by Z. So let us take it as second equation. So from first and second, we can say that I delta is equal to 3I star. So if the same impedances are connected in a star across the same supply, then the magnitude of line current will be 1 3 times of 1 divided by 3 times of previous value. So that we will get the conclusion. Now we will see the power consumption. So in power consumed will be in delta connected load 3 times phase current value into impedance, and for this IAB is equal to 3 into IA square divided by 3 into Z. So this will give P delta as IA square into Z. And for this a star connected load, simply 3 times of phase current value into Z. So on comparison with 4 and 3, this one take it as 4 and this we can take it as 3. So on comparing 3 and 4, from 3 and 4 we get as P star is equal to 3 times of delta. So P delta will be P star divided by 3. So the power consumption will be also reduced to one third. So the what will be correct options for this question number 9? The line currents will be one third of previous value and power consumed will be one third of the previous value. Now let us see the next question. Next question is which of the following is not correct about delta connected balanced three-phase circuits? So this one is very, as we discussed, this one very, if we having idea about a star connected system and delta connected system, and if you have idea about balance system and unbalanced system, you can easily find out the correct option for this question. The first option is phase current is less than the line current. So in delta connected balanced three-phase circuit, line current is root 3 times of phase current, as we can see in this ninth number question. So the first option will be correct because line current is 3 times of phase current. So phase current is less than the line current and it is a 4 wire system. No, it is a 3 wire system. It is a 3 wire system. So this one is incorrect. Phase voltage equal to line voltage. Yes. In the delta connected balanced three phase circuit, the phase voltage equal to line voltage and the system does not contain neutral part. This one is also correct. So which one is not correct? Option B is not correct. Let us see this 11th number question. A three-phase motor can be regarded as a balanced star load. A three-phase motor draws 5.6 kilowatt when the line voltage is 220 volt and the line current is 18.2 ampere. Determine the power factor of the motor. So what we have given value as P equal to 5600 watt and line to line voltage given as 220 volt and the line current is given as 18.2 ampere. So here we need to find out the power factor. So we know the active power equation as root 3 VLL IL cos phi. So from here 5600 watt root 3 times of VLL 220 into IL cos phi cos phi 0.80748, that is 0.8075. So the correct option will be 0.8075. So here calculate the line current drawn by 30 kilowatt three-phase motor having a power factor of 0.85 watt lagging if it is connected to balance source with a line voltage of 550 volt. So again we will use the same formula, that is root 3 times of VLL IL cos phi, and here the given values are power, that is 30,000 watt, power factor, that is cos phi given as 0.85, line to line voltage given as 550 volt. So only one unknown is line current. So active power is equal to 30,000 root 3 times of VLL 550 volt IL cos phi is 0.85. So from here, just putting all these, we will get the line current value as 37.049 ampere. So the correct option will be A. Next question is a star connected load is supplied from three phase 240 volt means each branch of the load is a resistor of 20 ohm. Calculate the value of phase current and power taken by the load. So what are the given values? V phase magnitude is given as 240 volt and each branch of the load is a resistor of 20 ohm. So resistance in each phase is given as 20 ohm. Calculate the value of phase current and the power taken by the load. So we can simply write I phase is equal to V phase divided by R. So 240 divided by root 3 divided by R. R is 20 ohm. Sorry, here it is not mentioned that it is phase voltage. So we have to take it as line to line voltage. So I have written here incorrect. So please correct this one. So this one is given as line to line voltage. So what will be the phase voltage? Phase voltage will be 240 divided by root 3. So now we will get the phase current as 4 root 3 ampere. That will give us as 6.928 ampere. Again, we need to find out the power taken by the load. Power taken by load will be for each resistant I phase square into R, and having resistant in all three phases, so the power taken by the load will be 3 I phase square into R. So this will gives you as 3 into 6.928 ampere square into R. The value of R is given as 20 ohm. So this will be gives you 960 into 3 watt. That will give you as 2.88 kilowatt. Let us see the next question. What do you mean by electrical load? So this one is very nice question. What do you mean electrical? Is it resistant? It is impedance, or you assume the electrical load by the power consumption or energy consumption? So sir has taught this thing very deeply in the lecture 3. What is the significance of electrical load? In lecture 3, you will you will get to know the about of electrical loads, and the lecture third is introduction to electrical loads. So if you want to learn what is the significance of electrical loads and what is the real meaning of electrical load, please go through this lecture number 3 of this NPTEL course. So electrical load, if we see in this lecture 3, electrical load definition is electrical load definition. So electrical load definition is an electrical load is a device. An electrical load is a device which consumes certain amount of power energy to accomplish certain task. So here we can see that an electrical device which consumes certain amount of power energy to accomplish certain tasks. So the electrical load always think about the power consumption and energy consumption. I mean, if anyone says that electrical load increases, then what you will tell, then power consumption increases or energy consumption increases. If anyone says that electrical load decreases, then what you will say, power consumption decreases or energy consumption decreases. So always think whenever the term comes electrical load, always think about this power consumption and energy consumption. So the correct option will C and D. And the same lecture you will get to another various types of load. Like if we want to classify this electrical loads based on dependency of voltage, then we can write as different types of loads based on the dependency of voltage. We know that there are three categories: constant impedance load, constant current load, and constant power load. So just briefly we will see that what are different types of loads. First one is constant power load, that is it is independent of voltage level. So demand is constant regardless of voltage. Demand is constant regardless of voltage. So it means that P, we know that P is data constant VI. So suppose if you reduce this V, then I will increase because it is constant power load. And if you suppose V, if you increases the voltage, then current will reduce. So whatever it is not dependent on the voltage, it always takes the constant power. Means if voltage level is down, then it will extract more current. If voltage level is up, then it will take less current, so that the power is constant. And the typical example for this constant power load, electrical motor. Electrical motors. And the second type is constant current load. Constant current load means demand is proportional to voltage. We know that power is directly proportional to VI. Since I is constant, then it means power is directly proportional to V. So, so the demand is proportional to voltage. And the example of this constant current load are welding units, smelting, and electroplating processes. And electroplating processes, etc. And the third type of load is constant impedance load. That is one of the most typical loads in the household. Constant impedance load, and in this power is proportional to voltage square. Power is proportional to voltage squared. We know that V divided by I is equal to Z. So I comes out to be V divided by Z. And since P is directly proportional to Vi, so putting I values at Vy/Z, so it comes out, since Z is constant, so it comes out as P proportional to V square. So this one is the constant impedance load. So based on the dependency of voltage, constant power load is independent of voltage level, and constant current load is dependent of voltage, and constant impedance load is proportional to voltage squared. So, and if we see the examples for this constant impedance load, then incandescent lighting, incandescent lighting, incandescent lighting, resistant water heaters, resistant water heaters, etc. So these are the commonly different types of loads based on dependency of voltage. So let us see the next question. Balanced three-phase system implies to. So what do you mean balanced three-phase system? It is having balanced source and balanced total. Balanced source means all phase voltage magnitudes are equal and they are phase apart from each other by 120 degree. And balanced load means all loads are of equal value. So the correct option will be A. And let us see that last question for this tutorial session. In a balanced star connected system with phase sequence AB, line voltage VA is fill in the blanks phase voltage VA. So in a star connected system, we know that line voltage magnitude is root 3 times of phase voltage, and it is it is leading by the angle of root 30 degree. In a star connected system, we can write this one as a star connected system balanced. So all phase voltage magnitude is equal. So let us assume this voltage magnitude is V at the angle of 0, and we take it as phase voltage at the reference. So VB is equal to V at the angle of 0 degree, and VC is equal to V at the angle of 0. Sorry, whatever. V at the angle of minus 120 degree, and this VC is equal to V at the angle of plus 120 degree, or V at the angle of minus 240 degree. So we have taken this phase A voltage as the reference. So the line voltage, so the phase voltages are given by this. So now line voltage, how we can write VAB, VAB, VA minus VB, that will give you root 3 times of voltage phase voltage magnitude at the angle of leads the angle of root 30 degree of phase A voltage. And VVC, we can write VB minus VC, and it also leads the phase B voltage by root 30 by angle of 30 degree. So minus 120 plus 30, that gives you as minus 90 degree. And VCA will be VC minus VA, that will give, that will also lead the phase C voltage by the angle of 30 degrees. So 120 plus 30, that will give you as 190, 120 plus 30, 150 degree. So these are line voltages. So here in this question, line voltage VAB leads the phase voltage, leads 30 degree phase voltage VA. So correct option will be A. So that's all about about this today's tutorial session, and hope you see. I will see you all in the next tutorial session. Thank you all for joining.